There we go. So the recording actually was still going. So the stream cut out because of YouTube. But suffice to say, this is just like it's like the daytime talk shows. They're like, this is how you build the recipe, and then we've already got one made. I'll just pull that straight out of the oven. So I'm working on it on the stream, and then the stream cuts out, and then it comes back, and it's done. I'm only kind of kidding because we still get to do this half. This half still needs to be reoriented. But actually, let's do that right now. So we have our initial point to 39 reoriented. Save that. And we're going to orient all the key switches around that new K39 orientation where it's just slightly off kilter. So we'll be recentering that and just making sure we're streaming here. Orient all the key switches around that new K39 orientation. Nice. This is the fun game of streaming on YouTube. Is it still working? Sometimes yes, sometimes no. Alright, so we had some tweaks to make to this half, which is just fine. We've already got this. Our angle is redefined here. And then we do our first set of keys oriented off that point. So there's our 39, and this keys above it should reorient it based off that position. And hey presto, there they go. These are realigned, and we're going to realign the keys left and right of that one. There we go. Copy that over. And the rest of the keys should T-pose on the haters. There we go. Now I look a little off. No, I guess that looks right. It's interesting. But we do need an updated snapshot of these keys, because those keys in that position are not, oops. Paste, there we go. We update the module snapshot for those keys that are left and right of center of the thingy. And then we're going to do a new best guess layout for them because they're moving off themselves. Where was I? Here we go. So we're doing K1, K2. Actually, these are laid out around the center key, so K3 and K5 move down 1/4. K3, K5. Well, these are all moving relatively this general direction. I think they'll actually move down on their own, but actually, let's test that. See what they do. Kind of a weird thing. We want it to be down relative to the previous position. That's much better. So then these other ones, K6 is going to go down like half a unit, as is K1 and K2. So K1, K2, 2, what did I say, K6 and K1 and K2? 5 and 6, yep. And paste that. Go ahead, you can do the thing. There we go, nice and aligned, look at that. Now we're angled T-posing. Since I stopped that stream, I'm actually not sure if the chat is... Yep, the chat's broken. Brilliant. This is just Streaming on YouTube. Living the dream. Living the stream. Okay. Now we do our align to column from top down. And hey presto, as long as it doesn't crash, we'll have all of our keys adjusted. This is the exciting part. Oh, there we go. So interestingly, these did the same thing. Hello? Shift G? You gonna let me move something? Move? It is Shift G. I did press Shift G. You want me to unselect? Yeah, I'll hover over it. So I'm just gonna freehand that and then move it more correctly. Using this. Yeah, these ones need to be oriented. So we've got K17 is going to move based on K5. 17, and then we've got K6 is moving based off K18. And then single unit, right? Yeah. 26 I think is still correct. And then this one's going down here, and this one's going down here. This is based off of K30. So K30 and K41 are orienting K60 and K59. Oops, that's the wrong spot for that to be, but it still worked. And I assume this also worked. No, it did not. Oh, I didn't even... I guess you have to actually type it in order for the code to work. There we go. Moved and aligned perfectly. Very nice. Very nice corners. That's what we're talking about. So here's our alignment. That's set up correctly. Now what's cool about this is if Kicad at any point crashes, this is actually... this whole procedural section is copy-able. I can just paste the whole thing in, and it'll recreate. In fact, I'm somewhat tempted to do so. just to kind of test it out. But our key positions here, I think these are all adjusted correctly. But this key position drops down a little bit further. It goes down an extra half unit off 47, but that's technically off 63, I guess. So we'll go corner keys 47 or 63 orients 47. 1.5 units. There we go. And we're doing something similar over here with K50, 64 and K58. Brilliant. Now we're all nicely aligned. Although I think our update included some changes to that position. Yeah, this key moves down half. We can do that as well. So this moves down half, and this is supposed to move down half of that, which means our K layout is 2. So let's do another one of those. We'll do 64, rather 46. That's a 9. I'm a genius. This is great. Case blah 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 blah. Okay, 2. It's 1, 2. Yep, that's right. And then over here we've got 37. 37, adjusting 48. There we go. That's the appropriate layout. Same thing applied over here. Looking good. So, the next thing, and the tricky part, the part I haven't written yet, is the diode adjuster. Because the initial layouts of the diode and the key switch relationships are saved in this the initial snapshot. So I need to figure out the deltas and then reapply them to the new key switch positions. Which is over here. Yeah. I think we've still got this. Yeah, so if I do, what is it, shift, control shift? Yeah. K, let's see, K1 and K12 probably move the most. Furthest from the rotation point. Initial snapshot K1. And then if we do the latest snapshot K1, wow, was that right? That's extremely different. It's almost concerningly different. Well, it's all good, I guess. This is the correct layout. Alright. But enough about that. The next position on this is... So we've got our initial snapshot of the diodes. Move the switches to a new location. Gather the original diode offset from the original snapshot. Apply the offset to the new switch position. And best guess the position, match all diodes to switches. Ah, right. Okay, I remember now. And then we get our angle here. Distance from an original position. And I think this works out to, yeah, final minus initial. Or diode minus keyboard, or key switch position. Which I think is how the math worked out. There it is, target diode. Target diode X minus switch X. So we need to calculate our delta off of that. So this actually might be a little annoying. Alright, so let's see if we can figure this out. Gather diode. Oh yeah, I had a clever name for this because I'm just so clever. Just a clever guy. The Diode Delta Diviner. Yes, this is... I should not be allowed anywhere near a computer. Call me Zero Cool. Learned LaTeX recently with custom code, listings, and custom captions. Define my own template. Now it's just easy to make new documents, and it looks much nicer than Word. It sure does. See, that's the power that programmers... I shouldn't say. Some programmers do understand. They grok that the power is in the repeatability and the slight adjustment. That's why stuff like OpenSCAD is so cool to mess around with, because you can make something and have a final product, especially if your product is documentation, and then make one tweak and hey presto, you've got a completely updated version. You don't have to, fiddle with things with your phalanges and your mandibles and typing things. You just go in and say this variable should be that. Done. Regenerate. And That's where the actual power is. Yeah, I haven't. My output is generally, my product is not documentation, but if it were, LaTeX is where I would be. I actually have a system set up for LaTeX on the cloud system because it's cumbersome to get set up on the development environment. I hope that's been improved since I tried it, but once I got it set up, I was like, I am not doing this again, so I'll just leave it on this cloud box. So if I have like org templates or org files that I want to drop out of Emacs, and I want to generate them as LaTeX files or PDFs, then I just copy it over there. Usually already exists over there, but you know what I mean. Regenerate the file on the cloud server and then pull it down. You pull the thing down, flip it, and reverse it. Missy Elliot and her bitwise operations. Alright, so I thought I already had... Yeah, I think I've got detail on how to do this. Yeah, so our target diode layout, actually need an original copy of where the diodes were to begin with. I think I have that over here. Let's put it on 7. Or did Inkscape? Oh wait, I've actually this is a picture of the Inkscape file that I'm going to mess around with. This is just brilliant. I'm not joking. It is brilliant. It's great software. I just don't like Microsoft. Right. If it doesn't have the diode layout, that's what's kind of weird about it. So I'm pretty sure K47 has kind of an odd diode position, so that'll be a good candidate to test this out on. So let's go to K47. There's K47. It's in more or less the same position. This should be D63. Okay, there's K47. D47. So this was originally like down here. Like down here. And now I want that to have the same relative position. How do you redo? Is it Y? Control Y. Control Shift Z is much... It's a chord, but whatever. So this is supposed to be moving like... kind of like that, I think. The center point right there. So that's where it should be winding up afterwards. Oh yeah, I wanted to know about our X and Y positions if they wind up being negative, which they do. So this will be an appropriate test. And then in here we should have, yeah, we're all positive. Okay, cool. I think the center point, the 0 point is over here, which is okay. You know, as long as you don't have gigantic keyboard circuit boards. Yeah, it's still not negative. It ain't not negative, so that'll be an appropriate test. Although I should probably test with 2 positive numbers to begin with. So let's... do K59 first. Yeah, that's a better idea. Okay. There's K59. Oh, I'm going to have to move these. That's okay. It doesn't matter. All right. Let's start with K59 since it's all positive, and then we'll test that afterwards. 9 initial snapshot. There we go. So what we're interested in is our snapshot, actually our initial snapshot. And Python syntax, K59. I don't know what's going on up there. And D59. There's our layout and our orientation, still that previous number, previous value. K334, that's updated. So what we're interested in is, oops, I think this is is this an object? No, it's dictionary object. What? Oh, this is stupid. Okay. And what I was figuring was the target diode X minus the switch X. I have no idea what's going on out there. It sounds horrifying though. I think I could do this. Does Python let me do this? This multi-line thing? Okay, that gives me my delta. X. That'll be easier to modify later. Hello. What's going on? Oh, I'm in the wrong. There's our diode delta. Saved correctly, yes? No? Hey, quit it, quit it, quit it, quit it. What are you doing? Okay. Let's do that. Copy it over. Y, X, Y, X, Y. K. I mean, Y. Y. Good. So now based off this original delta, this should be a positive value, which we're going to reassign by resetting the let me see, off the current board module reference. We need that down there. And then we're going to update get position. No, it's not get position, it's set position or something. Yeah, there it is. Set position off the snapshot module reference. And that's it. What is that? Oh, set. Okay, yeah, I got it. Okay, so that means we're gonna need got the module set. We're setting the position for what? Where's the reference? Oh, we define the module first. There we go. Yeah, off our module reference. So that means we're updating value D59. Let's do this. $59. There we go. We'll do this properly. Module reference. Module reference. Okay, so let's do switch. No, let's do key switch. User module reference. There we go. That. There we go. Diode Delta X diode module reference. Good, good. Good, good. All right. That should be working code. No? Okay, it's a multi-line. Okay. Good. Next, we find our module, because our target module is the diode module, because that's what we're moving around. Because the key switch has already been moved. Diode module. Now we're going to update the position based off of the snapshot position of the based off the initial snapshot position. No, it's not the initial snapshot position, it's the current position. Yeah. There we go. This is going to need to be broken out, isn't it? Okay. Module, WX point. There we go. We're taking the diode module, we're updating the position, and we're setting its position to the key switch module. Oh, okay. Yeah, we need to do the same thing with this. Okay. Key switch module reference. Good. Same bits of code, yes. Good. Now we're not pulling the snapshot module, we're actually getting the position of it. Switch module position X. Y. It's key switch module position. That's our X and Y. But we are setting it based on the new WX point defined. Let's do that. It's a little bit more readable. And then we're going to apply our deltas. All right. So that should, according to previous references, put D59 right about here. So that's where it should wind up after this is done. And we're just waiting while the GUI updates. Just watching our Mandelbox, our Mandelbrot. Okay. Then we're doing our diode X position and Y position. Is that going to paste there? Is it going to like that? Oh, look at that. It worked. Let's put these in parentheses just for fun. And add a space here just for readability. You probably don't put a space there. There we go. That's enclosed, that's enclosed, that's enclosed, that's enclosed. I don't like doing messes like this, but I can expand it out later. I'm not sure how this console is going to handle the pasting. So let's see what happens. Let me just double check here actually. So diode X snapshot. We're pulling the module reference for X and Y, and we're subtracting it from the key switch module reference for X and Y, getting the delta X, X and Y. And then our key switch module, board, find module by reference, diode reference, key switch reference. And we're getting the key switch position X, and we're adding to it the diode delta. And we're resetting the diode position based off the delta to the key switch. All right. So, like I said, this should move to about here. Okay. Well, oh. There it is. Ooh, it worked. Ooh, I'm smart. Look at that. Need the PCB refresh after that, after we make those tweaks. Okay, so this worked for D5 and D59 and K59. Let's let's complete the best guess match. Well, let's do the negative one first, because D60 or K47 is has a negative X position. So let's see if that works for this. So if I do what do I say, 47? Oops, 47. I can do the whole thing. Will it work? It doesn't look quite right. I think that's a best guess. Oh, that's right. No, that's correct actually, because that's supposed to be positioned there, and then it's gonna do a best guess off of it. I think that's what I said. Gather a snapshot, apply offset to new switch position, do best guess position, match all diodes to switches. It's that delta though. See, that's what's weird about this. If I calculate this is in a Cartesian, like relative to this position, the Cartesian layout of it. This is along that line. I mean, kind of. It's close enough, but the intended position is along that line. So if I do a best guess of this, best guess for we'll do that. Key switch module reference, and our position is going to be what? Oh, divided by 2. Yeah. So now that should reorient in the correct position. Haha, what? Okay, it's still D47 and K47. So like that's the wrong position for that. But something like this, where it's along that Cartesian line. 59, 59. Do that, and then we'll do another best guess. See, that should orient. See, that oriented correctly. There's still an orientation delta I need to figure out, but that's easy enough to repair with this rotation angle for 90 degrees. Let's do 45. It's a bit more useful. Then we do R, and yeah, we'll match the orientation layout later, but that's the correct orientation. The problem is this delta between here. It's going to best guess and match this here, which is accurate, but over here, this is in kind of a weird position. It isn't 26 though, is it? I mean, I can still like rotate it around. This is kind of where it's supposed to be, but the thing is, it's supposed to be like here, and this is actually a function of the calculating the delta off the initial position. So I can actually take the x and y of this and the x and y of that and calculate the distance between those, and then set that as the distance rather than this half unit with orientation, because the initial layout has that value there already. So we need something like initial switch diode distance. Little stuff, you know, 1 unit divided by 2 or something. And we're going to calculate that off our initial layout as well. That's all we need for this. Just need a little bit of code for that. And that'll give us the appropriate like relative position, because the diodes are not in uniform orientation to the rest of the switches, although it would be helpful to place all of them ahead of time. So let's start packaging this up. Diode Delta Diviner. Yeah. All right. It's going to take a numerical reference or any reference. I guess it should be the diode. We'll do that. We'll unset this. And then our key switch module reference is going to be the diode module reference with some fancy Pythoning. It should be something like where was I? Like, was it 2? I forget how that works. It's 2 on or 1 on, or it's like this or something. It has pretty cool string handling. It's one thing I will give. It's one thing I'll give Python. There we go. See, like that. And then we'll do a K, capital K. And that comes through just fine. So that's our appropriate layout. There we go. And that should come through. Yep, K47. Perfect. And we got this. Oops. We'll do that. Calculating the delta. I'll put this at the bottom. We don't need that yet. So we need to calculate our switch distance off the initial diode X and Y off the initial snapshot. That's actually, I should probably do that. Make this a little bit more functional. So we'll take the diode module reference and the initial snapshot, which is just fine. I also probably shouldn't have saved that. This thing is gonna lag. We're gonna adjust this. All right. Where were we? Oh, calculating our delta here. We've got these. Key switch module set. Diode module is pulled from the live reference, the current reference. And for the diode module, we update the position. We run a best guess against that and that with our angle set. So the angle is something that needs to be I'm gonna set it manually right now because it's slightly different. It's a 90 degree or 180 degree increment, so it's off of the zero axis. So if it's this way, it's still 26. It's just the delta off 360, and then the absolute value of that. So I'm gonna leave it 26 here, just because I'm hacking at it right now. So no. Okay, angler. I'm gonna just do this properly. Angle. K. I did it, and I hit save because that's a muscle memory for me, and it's a good muscle memory to have, but not when this network drive is all messed up and slow because they're streaming right now. That's why. Are we done? Okay, good. So the point, we need to calculate our delta, which is lol just Pythagorean theorem, no? I think that's all I needed. It's just the delta. Yeah, I think that's it. Alright, so we're going to get our distance by pulling our initial snapshot module reference for X and Y. And our initial snapshot key switch module reference. Good. And then we're going to use, say we've got our X and our Y here. But it's just the delta though, no? Because the difference between those is, difference between the 2 points is the delta. But it might need to be absolute. Yeah, I'm pretty sure. Hello? Oh, come on back. Yeah. Be friendly. Let's test with our current layout, because that should be half a unit, which unit is 90.05, and unit divided by 2 is 9.525. So let's test. Which I think I already did. Oh, I remember now. That's why I don't do it like this. Yeah, let's do that. It's just easier to run like this. And diode module reference equals D, what did I say? It's 259. It's faster to run this as like a REPL kind of. Let's put that there. Unit divided by 2, output should be 9.525 for the difference between current position of K59 and D59 for the diode. And this is going off the initial snapshot. Actually, the initial snapshot shouldn't be any different, actually. Huh. So if I do this, that should give me the correct values for the diode difference from there. Okay. So my question is, how much of this do I actually need to mess around with? Because the diode delta for x and y are my a and b for my a squared plus b squared equals c squared. Because what we care about is the initial difference. But I think we have to absolute it. There's extra a's in there. But we're gonna square it, so it actually doesn't matter. Whatever. This is good. Good practice. Sure. So yeah, that's technically not a difference. And then we want plus b squared squirt square root math squirt. No? Okay, I actually don't know what Python's square root thingy is. Let's do... That ain't right. It is SQRT. Oh my gosh, come on. Why didn't it show up as a keyword? So we have to import math. Import math. Oh, I'm sorry, I didn't know you wanted to do math. Oh, I already have math. Oh, math. It's QRT. That's why. Alright. Look at that. I did know it. What do you know? Okay. So that means this value should be the same as unit divided by 2. Press enter. How many extra parentheses did I have there? Okay. Absolute value. Yeah, suffice to say that was not what I was looking for. Why is it's not squared? How do you square stuff in is it caret? Here we go. Oh, it's multiple 2 asterisk asterisk 2. Okay. So that means absolute value. I mean, like I said, that if I'm squaring it, it doesn't actually matter. I mean, my notes say to do the absolute value, but what do I know? Okay, so that's actually right. 9524999, whatever. Because that needs to be multiplied by, wait, is that right? Yep, that's it. Cool. So the other thing is, once these modules get figured out, the positions are pulled, but there's also a scaling that takes place. There's our scale. We multiply by scale because the distance is reset for that when we convert. U P D A asterisk J bum. What? Is this supposed to be divided by scale? I don't know which way numbers go. 9254. Yep, that's it. All right, so there's our code. This is our distance. Distance equals that. Good luck, everyone. Good luck figuring that out. Diode delta exponent 2, diode delta y exponent 2 divided by scale off the square root. Yeah, that's right. And that's our initial diode distance. That's accurate. Cool. So that means that that is correct. But now we get to do the initial layout for this one, which, like I said, is supposed to be about here, but it wasn't. Because the initial distance off best guess is... I already do a move though here. I update the switch position. There's the best guess. No, this is right. This is right. I set the position, and then I do the best guess. Yeah. Alright, cool. So let's do what did I say? D47. So it's D47. We set our key switch module based off that. Get the initial snapshot. We can find the key switch module. We move the diode. We calculate the distance. And then we do a best guess and refresh the screen. Alright. So this should have been like down here or something. Yeah, that's the initial position. And what should happen is it should move. Okay, let's step through it actually. I don't want to get too ahead of ourselves here. So where's the actual first change that takes place? Key switch module, we set the position. We'll paste that in. So we stopped there. We'll refresh the position. Okay, so that's correct. And next we calculate the initial distance. And just for my own edification. Good. And now we'll use this. And the best guess actually should do a refresh on its own. So that should put this from here to here, just about. Okay, well that wasn't what I was expecting. What happens if I do this and then do that again? Where'd we go? That ain't right. So our switch position is based off of the initial angle. And I think the problem is that this isn't at the initial angle. This is the appropriate distance, but this follows, the math of this follows a circle, an arc around the center there. So when I say this, the edge cut, let's say, if I go like this, boom, and go to this center point right here, I think what is happening is this needs the corrected angle. because this is the initial angle, but it's not actually at that angle. It's actually at this angle because it's right along the line of that. So what needs to happen is the angle needs to be recalculated off the initial position, because you're figuring out what the deviation is off the 0 point, the apogee of the circle thingy. These are all very complicated math terms. I don't know if you know this. Suffice to say, this is close enough for government work, I think. Yeah, so some of these are a bit off, which is fine. I'll probably have to match orientation, but this is good enough to get us started here. So we've got our angle, our snapshot. The scale should go off the original distance. So we do that. This is actually not necessary. Some of these might be a little wonky, but oops, don't need that, and don't need that. Let's add that function in. Good, it accepted it. And now we'll do the Diode Delta Diviner. I'll kick off the columns. What are we doing? We could go off a list. Diode module reference. Yeah, where do we go by the list here? Don't need that. For target for diode in D. Is that still set? Yep, still set. That's our list of diodes. Do a Diode Delta Diviner function off of diode. Technically, this is a diode module reference. Yeah. Diode. Is that right? Did I spell that wrong? No, I didn't. It just looks weird. I've looked at diode sufficiently that the word looks weird to me now. Congratulations. Diode reference is set. Our initial snapshot is the same. Our angle is 26. That increments. Technically, I could do a list comprehension here, but I actually don't care. So when I do this thing, all the diodes should move to the right things. Ready, set. Let's do some tests first, so this whole thing doesn't crash. just testing for a friend here. Let's do D. Let's see what we've got. See, this is a big mess over here. Let's try this. These are all oriented weird, but relative to their host switch positions, they should be actually pretty obviously placed. So 7, 8, 19, and 20. I think. I don't actually know what those diodes are. So here we go. Actually, they're right here. So we've got 8, 7, 19, 20. Oh, I was right. Okay. What did I say? 7? No, please don't. 7, 8, 19, 20. All right, see if these do the thing. this one's wrong. I know that. But this one is, it needs to be rotated, but the D delta on the left, I have code for matching the orientation, pseudocode for matching the orientation. That, and then this one is, I don't know what's up with this one. Why is K8, whoops. Like should be around here. If I do this and do D7 again, oh, D7's like far away. Oh, that's actually a function of the circle. That's what I was talking about. So this distance, the correct placement is like right here. And if we do our circle again, I expect that we will find. That this incident point is right in the middle. Do this, and then we'll do some lines right here. That's not right. Right in the middle. Up to here. And our point of incidence should be close enough. Like this is what I'm talking about. This is supposed to ride along this edge right here until it gets to this point where the intersection is. So it's the correct distance. It's just not the correct location for it. So some of these might need a little bit of tweaking. And in this case, like D7 is actually best oriented off of K8. So it might need a little bit of tweaks, but it actually looks really good. And just because I said I would and said I could, and this is probably cleaner as one, I'll do a list comprehension. I for, oh, I can't really do that, yeah. I for single for, okay, forget it, doesn't matter. This is why you use descriptive variables. I for I in D diode delta snapshot for diode reference I for I in D. Well, let me back up those changes. Those are not necessary. Whee! Look at them spin. All right. Here's all the diodes forever. And so that the PCB refresh is actually, that's probably the problem, is when I run that each individual time off the best guess, the refresh, it's stacking the refreshes. So I'm guessing that's what the delay is when that comes up. So I'm actually kind of curious if this best guess, if I get rid of that from the best guess, drop that in there, and then go back to my string of code. There we go. Do this and then do a PCB refresh afterwards. I'm actually pretty sure, because that doesn't do a PCB refresh, that just updates the values. Okay, just because I'm... Is this right? Am I remembering this right? I want to do something that is a reference module off of this. I'm kind of curious to know if this works. So I'm actually going to test this first, because I don't want to crash. I would rather not crash right now, so I'm just going to test this list comprehension, because I always seem to forget the appropriate values for it. Diode. We'll just do something simple for output. And like that. So if I do that, yeah, that's perfect. Okay, so I did have the right values. I just do that, and then it's done. And now I'll do one PCB refresh. Cool. So anything that's on a direct that Cartesian layout like that I was talking about with its direct reference, like this value straight down the middle or straight to the side, like that cross, anything that's along line with that cross is perfectly placed. But I need to calculate the previous angle of the rotation. So this is actually, see, match distance, I got that. I didn't have the transform angle diode from original. That's the problem. So that's, I just snapped all of the diodes into their appropriate positions, and I'm just going to have a little bit of code to match the orientation from the original. But this is an excellent start. And plus we're super fast now that we don't have that PCB refresh happening in the background after every single update. Except I saved the file, and it takes a long time. So that's fantastic. Computers are kind of cool. Alright, computers, you can hang around this time. Dear computers, you're pretty cool. Come on, there we go. Nice. And the Minecraft server is still chugging away. See? So few dropped frames. It's amazing. That's not true. So many dropped frames. The other thing I wanted to mess around with, which I might try really quick, is setting up our filter selection for these traces. I might just snatch these right about here. And then we will filter our selection to only the tracks. And then we will rotate general, I think it's 10 additional degrees. Then we're gonna press R. Then we're going to move them and then be like, it's cool guys, I got you. Right. 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 We're so close here. With the diodes aligned, it'll be a little bit easier, but like... Ah ha ha, there we go. I can see an appropriate lane for adjusting the values. So now our traces... Our traces are all aligned. Oh, this is brilliant. This was going to be very cumbersome, and now it is not. And that's kind of all right. This will be like around here, I think. Yeah. We can G, R. And then I can reassociate those off of the nearby switches. Brilliant, brilliant, brilliant. And then this boy, we've got 10 degrees. Yeah, I'm not going to press that 9 times. Or am I? 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. 2, 4, 5, 6, 7, 8. I press it 18 times. Yeah, if we match our rotation, then we'll have it. This still seems a little bit off, but man, that's a lot of effort saved. This is the scales upward. Yeah, see, this is off. These are still lagging a little low. And I'm not sure. Oh, that's right. So these traces are actually, these switches were actually mounted an eighth of a U lower on the, yeah, an eighth of a U unit lower. So these traces are in their correct positions. The switches are just in an updated position. So that's the problem there. Everything else works. That is brilliant. Ah, that's good. It's going to be interesting to rebuild, but man, I'm going to do it. I'm going to do the thing. I'm going to press the save button. Yeah, I'm gonna press the save button. I still have the initial positions, and I don't want Kicad to crash and then dump all the positions. And hey, look, it's all the data. Save. Let's just that's not what I wanted. Copy. Sorry, I guess we're not doing that. Pit. Am I a joke to you? Copy. Escape. P. I have concerns. Is it in the plus buffer? Is it in the asterisk buffer? Oh, it is not. Oh, this is... What? Wait, I think I get it. Copy and then deselect. There it is. No. What on earth is... Oh! It's truncated. It was copying every time. So these are all the values. I can re-enter them if I like. I think I locked it up. Yeah, Emacs does not work great with some of this Python syntax, especially these breaks. It's treating it as a single line. It's weird. It'd be funny to crash Emacs before I crash Kicad. But just to, you know, just to be silly, we got it. Are we good? Are we cool? I don't think these have any double quotes in them. Yeah, the quote matching is all screwed up. Let me undo the lines here. Yeah, 8,272 characters. So that's just fine. Equals. Ta-da! Saved. That's worth saving right there. All right. How did the rotation of grouped keys work out? Worked out swimmingly, fantastically. Was smashing. The other tricky part was the rotation of the traces, which actually worked, or figuring out the rotation angles of the diodes. So there's a little bit of work to be done there, just because not all of these diodes are positioned appropriately. But basically, we collected all of the. We collected the initial snapshot of the initial positions. We determined where the diode was in relation to the key switch that it's related to. So like K1 and D1 and K59 and D59. Figured out the delta between them. Got the current positions of those modules. Figured out the Pythagorean theorem, the distance between those 2 points. And then reposition them, and then did a best guess, that best guess function off of the initial switch diode distance. So we actually need to recalculate the angle, because right now I'm just manually setting it, but once we recalculate the angle so that it matches the original angle calculated off of the initial position, we'll be able to angle some of these weird ones correctly. But everything else also need to match the orientation. Like these need to be oriented so they're in the same orientation. Well, that's actually correct. But like these need to be in the same orientation as where they were left. But then after those diodes were in the right position, was able to grab all of this, filter by just the traces, and then rotate 10 degrees and move from there. Because this all appears to be lined up, which is just crazy to me. See, here's my 10 degree tilt affected over here, which is pretty funny. Let's see if we can do it over here. So we actually had the same problem before with that. We can only rotate by 90 degrees, but it's 90 degrees stepped in the opposite direction. So what did I say we had? Was 360 minus 10, which is about 350. I think I remember this. Divided by 4 is 87 degrees. So these are all updated. So we'll set our rotation. This is the thing that we did last time, which is hilarious, but better than manually rerouting all of these traces. So let's do this side real quick. Let's grab... I don't actually need those traces, but some will get grabbed. Right about there. We'll grab those. Filter our selection, doing just the tracks. And now we get to do the weird stuff. We're going to move them. We're going to press 1, 2, 3, 4. Oh, unbelievable. It's so weird. It's so hilarious. And I think this goes up and around, or am I wrong? So this goes like this. This should be about the right position. It's just about that. But some of these look like they're in odd places. Maybe like that. A little lower. I think that's it. I think that puts all the lines through where they need to go. Some of this still looks like it's not lined up correctly. We're just kind of eyeballing it though. This one doesn't have, some of this looks a little off. And this is what I was talking about with the rotation, is some of the rotation is, I think it bleeds, like the float miscalculates. You've got some leftover angles in there, so it's not exactly 10 degrees in the opposite direction. So this might be as good as we get. So this lines up here. Yeah, I think this is as close as we're getting. That goes there, about there. There we go. So that's not bad. Yeah, see, we've lost some of this here. So this might need some work. But that's the Kicad free look, flipping things around. The scene graph. So the scene graph, your idea about referencing the original positions off of the I don't think there's a scene graph like a plugin or add-on for this, but I wound up using the initial diode reference, which I think was the substance of your request or substance of your suggestion, using the initial diode layout in reference to the host key switch position, and then calculating off of that. So I would say I did my own kind of scene graph, I think, if I'm understanding scene graph correctly. But yeah, it was a helpful thing to provide that information. Thank you. And it seems to be working. We just need to figure out how to move these traces around. Might even undo that too. How many? 3. Oh, we're past Are we past undoing? Maybe Kicad's just gonna crash on me at this point. We'll see. I don't care. A lot got done. Yeah, there's still gonna be some rerouting going on here, but it should be pretty minimal. And I won't have to rerun everything. And I should be able to just drag these entire segments into alignment. Very nice. Very nice. Thumb clusters are still being finalized though, so that'll be good. I think I've got my initial snapshot set, so I think I'm ready to hit save. This is where I begin to doubt. I'm trying to think if I have anything. Yeah, I'm gonna save a copy real quick. New name, sure. And we'll adjust this later if we have to. But we can step forward with all the changes that we've made through our procedural mess of code through all of these key placements. There are a few manual moves in here though, but technically I can automate those by just applying some. Oh, that's good. And I think we're good. Yeah, see, that's the kind of thing that gets me. You need to do a bit of work to fully implement a scene graph, but whatever works. Yeah, that's like, I'm not sure how much I want this to scale. If this were something I was spending 10 hours a day working in, then yeah, absolutely, I would want to be able to program in or write some functions that would pull out associations between different Kicad modules here and their relationships to each other, and just keep track of them so that I could modify one and then have all of the changes spiral out from there, and all the other bits that are associated, reassociate themselves in the updated positions. So we're kind of tracking that. We have our initial layout, our initial snapshot set, and we do our calculations off of that initial snapshot, and we figure out what our values are and then apply those values with our updated deltas. So maybe there's more to be done here. I'm not sure what else I would need for my personal uses, mainly just moving these positions around in relation to each other. There's a rat. Oh, man, this looks so off. I like this sweep around. That's so weird. It's like the whole thing is off. But did it catch up? Is that the problem? Is that why the rat nest is all sideways? All right. Well, this is a good stopping point. I think the stream cut out in the middle because, yay, well, sure, why not? So I might have to hack these together. But good work.